Now, number 9, what was her average velocity for the entire trip? So, if we go back up to the very top of our definitions, they are coming in handy. Speed in a given direction is called velocity. Direction, it's that north, south, east, or west direction, okay? So, going back to question 9, what is her average velocity for the entire trip? All right, so we have our speed, which is 160 meters per minute. Now, here is our velocity, east, 160 meters per minute east. Where did I find that east? Right here. Maria's house is directly east of Ashley's. We plug that in, there's our answer. Number 10, Ashley stopped to talk with another friend during her trip. How far was she from her house when she stopped? I got an answer of 800 meters. So let's look at our graph right up here. So we know if we have a flat line, we are at rest. Ashley has stopped, okay? What point did she stop at? 800. Okay, that is how I got 800 meters. Number 11, match the descriptions below with the graphs. Be sure to explain your answers. So another one of these tricky ones, okay? So graph E, which is this guy right here. Graph E matches description 7 because the speed is increasing. Okay, so we can see that we're having this line and it is shooting up. The car is accelerating. Graph F matches the description. Here's graph F. Description 8, the car is slowing down. You see we have a different type of line. It is slowing down, it is more narrow. So the speed is decreasing. Graph G matches description 6. The car is traveling at a constant speed. Okay, so if we are at a constant speed, then we are moving at 0. Believe it or not, we did cover this, okay? So we are still at rest, that constant speed. We are not changing direction. We are not changing our speed. We are traveling at 10 miles per hour, giving us a flat line like this, okay? Speed is not changing. And graph H matches description. Here's graph H. And if you notice that dark line down here matches description 5, the car has stopped. It's not moving at all. Okay. Now, number 12, which runner won the race? Explain your answer. So we have 3 runners, Albert, Bob, and Charlie. Let's zoom in. In 18 minutes, they were given to run 100 meters. All right, so which one met that 100 meters first? All right, Albert, because he reached it first. So you can see in a shorter period of time, Albert reached 100 meters in 12 minutes. If we look at Bob, Bob reached the 100 meters in 14 minutes. And Charlie reached the 100 meters at, it looks like, I'm going to say 17. Yeah, 17 seconds. I'm sorry, I think I'm saying minutes. 17 seconds. So Albert did reach it first. Number 13, which runner stopped for a rest? So remember, if we have this flat line, there's no movement going on. We follow up this line. Hello, we have Charlie right here. Charlie stopped because the distance did not change between 8 and 13 seconds. So here's where he stopped at 8 seconds and 13 seconds. How long was the stop? Well, simple math. 13 minus 8 equals 5 seconds. Number 14, how long did Bob take to complete the race? Explain your answer. So here we have Bob, 100 meters, the end of the race line. Go straight down to time. Bob took 14 seconds. And now we are going to calculate Albert's average speed. So we are given a distance of 100 meters. We are giving a time of Albert of 12 seconds. STD triangle coming in handy, okay? So we have 100 meters divided by 12 seconds gives us 8.33 meters per second for that speed.